We're going to look at the vector STL. Notice the vectors, the word vector, you fill in a type. It could be any type, including an object. We'll talk. It's a generic template referred to as a container because it holds things. You can use it exactly like an array. Its contents are even contiguously assigned, so it acts like an array. Except it has a powerful set. There are extra methods to increase it, shrink it, ask it how large it is, etc. And it works well with iterators and algorithms and functors and tuplets and things. The vector has many member functions. To build it, to destroy it, the assignment operator, you can ask about its size, you can modify its contents, you can directly access elements, you can use the standard array operator, or you could use, say, @, or dat. And you can see there's some extensions. You have iterators that allow you to start from the beginning, go to the end, start at the end, and increment towards the end and go to the beginning. That's what reverse begin and reverse end means. Constant begin and constant end, which means you can move through the system, but you're not allowed to change anything. You can look, but can't touch, and you can go in the reverse direction, looking and cannot touch. You can design your own allocator, how new memory is allocated. And there's a specialization. You don't have to write bool. It's already been done for you. All right. I took the liberty of going to c++.com. There are many, many websites that are wonderful sites to give you reference material for all of this, but I just picked this to be consistent. And these are libraries that we're going to be using, the Iterator and the vector library. So let's start. You probably have already played with vectors a little bit, so this shouldn't be too new. So to reinforce it, we're going to create a vector. I use the namespace std because that's inside a namespace standard, using the scope resolution operator. Vector filled with integers and call it vec. And here I assign it automatically these numbers. I would like to see what I just did. So I'll create a function or a method called display all. Constant, the vector integer reference vec, I call it. This means you can't change it. This tells me what type it is. This means it's a pass by reference. You don't make a giant clone copy of some creature that might not be easily copyable by default copy methods. That is, you have to do a deep copy. So here we use the auto. It says automatically tell me what V is. Go inside vec, pull out the items. Next, after I have an item, I print it out, skip a line, and then skip a space at the end of all of it. So now I have my main program. I create a test vector, and I say display all vec, and I get to look at these numbers. Beautiful, worked, very nice. Notice my main program is small, and to support my main program is this function, which is on top somewhere. But raw numbers have no meaning. I mean, what the heck does 1, 2, 3, 4, 5, 6, 7, 8 mean? So to fix that, I'll add this thing here, a constant string message. I say constant, I'm just telling the programmer, whoever messes with this code later, they don't accidentally try to add something to message or change vector. So now this will be added to the top of it, and it gives me the ability to say display all test data vec. Now it has more meaning to me when I look at it. Here's the program. There we have display all. Here's our main, create a vector, and test data, and this is the output. It's probably a good exercise for you to type this in and modify it a little bit. Here I show that a vector is like an array. It looks like an array here. I have the before, display before. I set vector element number 4 to -1, 0, 1, 2, 3, 4. This is element 4. And if I look here, display all after vec, you will see number 5 has now become a -1. We can also expand the vector with this word pushback. push back the number 9, and at the end of the list, you'll see the number 9 appear. It could have been any number. I picked 9 just so it's easier for us to read this to know it is working correctly. I can also remove elements. I can say, vector, I want you to erase element number 5 here, 0, 1, 2, 3, 4. It's actually 4, but it is number 5. Erase it. So I say, go to the beginning. There's this word, begin vec. This returns an iterator, which is like a pointer to the inside element, and I say move over 4 elements from that. So it got a pointer to the number 1, moved over 4, 1, 2, 3, 4, the 4th element, 1, 2, 3, 4 is 5, and it said erase it. 5 is gone. Notice 5 is missing. Notice everything shrank, or at least the element was moved. There's a space for an element there. Next, I'm tired of typing std. I'm going to get a little lazy. This can cause problems in larger and more advanced code where you have different namespaces and things may overlap, like you have an X, standard namespace X, and now you have, say, Muller namespace, and I have an X there. And so it's good to fully qualify things often. All right, so here we have our vector. 1, 2, 3, 4, 5, 6, 7, 8. I displayed a vector because I want to see what I'm doing, and I create an iterator. Notice this long qualification here. Standard, go to vector, go inside vector, pull out an iterator, call the iterator a pointer, and set that pointer to the beginning of vec. Now there's a word called next. You give me a pointer, move over to the next 3. Basically it adds 3 to pointer. Now, I don't want to write this whole thing out, std vec integer iterator for it. So I use the word auto, and it will automatically, the compiler will figure this out because that's what next returns, and it will be an it. And here you see the it is an iterator. It's basically a pointer. So I have to say, tell me what it's pointing at. You just can't say it equals 99. You say, dereference it. Go to what it is pointing at and set its contents equal to 99. And I do the same thing here with displaying the contents. I get a little lazy. I don't like, again, using typing up everything, so I'll use std namespace. So notice std can disappear. There are some spots here that I missed it. Notice I don't have to type in that long variable qualification there to get an iterator out. And this is what my output will be, playing around. I suggest that you change these variables around, change this, shrink and grow this, and play with this. Code, this is the way you'll get better at it. Practice makes improvement. All right, and here we do the same thing. We're just changing every round, and all I really changed is the word it. It was weird. This iter, I-T-E-R, this is what most people will use, and I want to do what most people would do. Excuse me. All right, wouldn't it be great if instead of using display all to vector dot comma vec, that's kind of limiting, because what if I want to say more things at the end? I have to call this function and then use cout. It's very, very awkward. Look at this, cout. And I have to do all this stuff here. Not fun. Wouldn't it be great if I could just say cout, my data, and then put my vec in here? Well, we can. Cout actually works like this, cout. This insertion operator is right here. It's called operator, and the double chevrons, or the less than symbols, whatever you like to call it. When the compiler sees this, it says, left-hand side is cout, right-hand side is a vec, and we could get it to call this function. So we could write a function called operator, cout, comma, vec. What would it look like? It would look exactly like this, pretty much, except we have to return things. So there's our new function, operator insertion. My first parameter is give me my output stream reference. I call it out. You could have called it Donald Duck, doesn't matter. Next, I have, if the compiler sees a constant, something that can't change, vector integer reference, I call it vec. So this is the right-hand side. This would be the left-hand side. Take vec, pull out one v at a time, one element, send it to out, and then return out. Notice out is an output stream, just like this. That'll allow me to cascade things. So let's see if it works. Operator, cout comma vec, and there it is. Cout says this, and then I say cout comma vec, and it prints out the vec. But I'd like to combine these two together. I really don't want to use a function so directly like this. I want the compiler to handle the work. So with this thing above my code, display is now gone. This is my new function. When the compiler sees this piece of code, it will break this down into multiple calls to this operator. First one will be the output operator, cout my data, which is passed then to output operator, cout vec, and so on to end of line, giving us this beautiful output right here. So it allows me things like this. If you want to investigate further, here's C++, Geek for Geeks, studytonight.com, tutorials point. There are, again, many, many others, too numerous to list here. Hope you enjoyed that. If you did, give it a thumbs up. Thank you.